Okay, let's take a look at this right now. We're doing Chapter 7. This is Chapter 7 test that's in the actual book. And we're going to look at right now the word problems. We want to focus on the word problems. We're finding out that this is where a lot of students have difficulty, and it's understandable. So we're going to go through, of course, 19, 20, and of course 21. And it says school dance. Each ticket to a school dance is $4. The total amount collected in ticket sales is $332. Write and solve an equation to find the number of students attending the actual dance. All right, let's deal with the first part of it as far as that. We're going to write this out as far as how the actual equation really should look when you first get it. We're going to go over this real quick, and I'm going to write something down. I'm going to start right over here. And the first thing we want to do is write the equation to number 19. It says, I'm going to write it out as far as words. The cost of each ticket, okay? I'm going to write down cost of each ticket, okay? Cost of each ticket. Then I'm going to go under this as far as that, and I'm going to times that. Cost of each ticket times, okay, the number of tickets sold. The number of tickets sold. We're going to have an equal sign, equals, okay, the total amount, or we're going to say total amount, put it right here, collected, it's money collected, put that right there so you can get it legible, collected, forgive my C, there we go, now it's a little bit more legible for you, in tickets sales. Alright, let me make this S a little better. So we have is the cost of each ticket times the number of tickets sold equals the total amount of tickets collected. Okay? Do everybody understand that? That's the written part. That's what we're getting out of this when it says school dance, each ticket to a school dance is $4. The total amount collected in ticket sales is $332. Write and solve an equation to find the number of students attending the dance. So I'm writing this out for you. It's like the cost of each ticket. What is the cost of each ticket? Each ticket is $4. Okay? I'm going to write that so you'll know it. So each ticket right here is $4. Okay? That's $4. All right? Then it says the total amount. And now we're wanting to find the total amount collected with ticket sales. The total amount that we already know that's given to us is what? $332. All right? Now we're going to find out what we don't really know is the number of tickets sold. Now let's write out this equation so you would see how it would look and how you're going to write it out when you get an actual question like this. Now here's the actual equation of how we would write this out. Okay? I'm going to write it out for you. It's going to be 4, which represents what? It represents the ticket sales. You got it, or the amount, of how much each ticket sells. Okay? We're going to say times for 4 times, and I'm going to use the variable in. We talked about variables, okay, in this chapter. Variable in, okay, which stands for what? The number of tickets sold. All right? You can make whatever number you want or whatever letter you want as far as representing an actual variable. I don't want you to get confused with that. But we always want to use something that's similar to what we're trying to find. In this case, the letter N represents the number of tickets sold. All right? Now we're going to say equal. Equal what? You got it. A total amount of tickets collected. And that's going to be what? You got it. You said it right. $332. We don't have to put that dollar sign right there. I don't want to confuse anybody. You can use this, put the actual number. All you need to do is put the number down, which is 332. Okay? Now, how do we now find the number of tickets sold? Well, we're timesing, of course, 4 times n. So what we're going to do is add these together, but since n is a variable and we don't know what that actual variable is, we're going to do this with it as far as that. We're going to just say 4n, you got it, and you know with an equation, we of course have to, if we put something on the left side, we have to put something on the right side. If we put something on the right side, we have to put something on the actual left side. So we're going to cancel this out right now, okay? Now on this side, we're going to cancel the 4 is going to cancel out the 4. It's division, so it's canceling each other out. So what do we have left? You got it. N would be left. So we, of course, whatever we put on the actual right side, we have to put it, of course, on the actual left side. Wherever we put on the left side, we have to put on the actual right side when it comes to division. Okay? So now we are just going to divide 332, of course, by 4. And what is your actual answer? When you all do it, you got it. It is 83. And that's how we come up with that actual answer. Do you need me to do the actual division? I have no problem. So I can show you exactly how we came up with n equals 83, which really means the number of tickets sold. N represents the number of tickets sold. I'm going to make this little line so you'll know it. Okay? Well, matter of fact, I think you've got that. So I'll get that out. But N represents the number of tickets sold, and the number of tickets sold is what? 83. Now let's find out how we got that. Okay? Very, very, very simple. You all are doing great. I know a lot of you all got it. I'm going to put it right here as far as the actual division. Do this right here, a quick division. We know how to do that. 332. How many times does 4 go into 3? We know 0. Alright? So we're going to move past that. How many times does 4 go into 33? You got it. 8 times. And that will give us, you got it, 32. We have a remainder of 1. What we're going to do is what? Bring down, bring down the 2. How many times does 4 go into 12? You got it. 3 times. Remainder is 0. Alright? And we're looking at this. This is 3. And that's where we get this. So as you all can see, everything is right here for you. Enjoy it. Good job on that. Good job. Alright? You all looking at that? Fantastic. Excellent job on it. Keep up the great, fantastic work. Alright, good job. Okay, now let's take a look at number 20. Okay? And let's see what we got as far as that. I'm sorry about that. T-shirts. A soccer team will sell T-shirts for a fundraiser. The company makes the T-shirts that makes the T-shirt charges $10 per shirt plus a $20 shipping fee per order. A. Write and graph an equation in 2 variables that represents the total cost of ordering the actual T-shirts. Okay, I put actual in there, but it says ordering the actual shirts. Okay, so let's take a look at this right now, and we're going to get on this. So the first thing I want to do is show you what we're talking about, how it looks as far as the word is concerned. So as far as the word is concerned, what we're going to do is say total cost. Okay, let me write this over here. Total cost, okay, equals what? Shipping fee all right, plus cost per t-shirt. Plus the cost per t-shirt. So we have the total cost. I'm writing this out for you so you can get a feel for it. The total cost equals shipping fee plus cost per t-shirt. Okay? Excellent. Let me get that off for you right quick. So we have that right there. We're going to move that because I'm going to use some of this actual space. Let me erase this real quick. That's the written part of it. And now, what is the variable? The variable in this, we're going to let the variable be, well, let's take a look at it as far as the variable can be, let's say C, which represents the cost of ordering the t-shirt. So I'm going to put right here variable. All right. And that is, the variable is the cost of ordering a t-shirt. Variable equals total cost. I'll be specific. Total cost of ordering the t-shirt we'll give that of ordering a t-shirt, and I'm going to say the variable then equals C. Let's say that variable equals C. Okay, so the variable, let me make that C a little bit better so you know what it is. The variable equals C. Alright, now let's take a look at this and see what we can do as far as that. Let's deal with the actual equation. How would this actual equation look? So the equation is going to look like this. Let me write it in here as far as that. The equation will be something similar to this. C equals 20 plus 10 times, do the times sign, T. Alright? And we know what that basically means as far as that. The T, of course, is going to represent the actual t-shirts itself. Very, very, very important. Okay? So let's take a look at that. So we have this. This is our equation. C, which is the cost of ordering the t-shirts, equals 20 plus 10 times T. Okay? Times T. Times the actual t-shirts ordered. Okay? And let's go from there and see what we basically get as far as that. And go from there. Now, if we look at this, let's just do a little chart. I'm going to get this off real quick. And that way we're going to do an actual chart. The number of t-shirts, okay, which is T. That's the number of t-shirts. That's what it represents, the number of t-shirts. In this case, I'm going to say 1, okay? Let's just use 1 t-shirt ordered, okay? And let me put that in here. Just 1. I'm going to get some of this out of here for us because we already have that. You already know what all those are. We already have the equation. But I'll put the equation back up there, okay? I will put the equation back up so we'll have the equation up here for us. I just want to get rid of some of these, okay? And go from there. Let me get rid of some of this. I love that. Wouldn't that be cool if the eraser could make that sound? That'll definitely keep you awoke. Okay, so let me write the actual equation so you all will see it. Once again, the equation is what? C equals 20 plus 10 times t. Okay, that is the actual equation. Now let's deal with what we call, I'm going to just break this down so you get an understanding of how it basically works. The number of t-shirts. All right, the number of t-shirts is what? T. Right? So I'm going to write this down so you'll get it. Number of t-shirts is T. That's what that's representing, right? So I'm going to put that down so you know what it represents. That represents T. Alright, so we already have that. That represents T, and we're going to say 1. Okay, so you'll know what that is. Alright, now that's 1. Now I'm going to put something else on here for you so you can get an understanding and look at this actual variable. Matter of fact, I'll put the chart down here so you all can understand exactly where it's at. Okay, so I'm going to erase this real quick, and that way you can put the chart here, and that way you'll see exactly what's going on. Okay, because I want to make sure you understand what's this and what's that. It's pretty simple. I just want to make sure you get it. Alright, and go from there. T-shirts, I'll just put t-shirts, which is T. We already know that. Okay, now we're going to say, I'll put a line right here to go through this, and I'm going to say C equals 20 plus what? 10T. That's the number of t-shirts, right? So we know right now we've got 10 t-shirts just for this equation right here. I'm going to put another one right here. Forgive me. That's my line. I know. Total cost. Alright, the total cost we're going to say is what? We already know what that is. It is C. We already talked about that earlier, right? And then I'll put something right here. This is like just a little small little graph so you can understand exactly what's going on. Ordered pair, okay? We're going to say the ordered pair. What is that? The ordered pair would be, of course, the t-shirt and, of course, the actual cost of the t-shirt. Okay? I'm going to say ordered. Oops, I'm sorry. I made a P instead of a D. Ordered pair. Alright, and I'm going to put this down so you'll know. That's what. You'll know exactly what that means. That would be the T. I like a T. That's a cool T. I like that T. And the C. And I'll, of course, put in parentheses so you all can definitely know and see what's going on. So that's what that is. So let's do the first one. And let's say if I said the number of t-shirts is something simple. How about the number of t-shirts being 1? 1 t-shirt ordered. Okay? So if it's 1 t-shirt ordered, it would look something like this. For 1 t-shirt ordered, it would be cost equals 20. We know that. That's given to us. Plus what? 10. Put this in parentheses as far as that because you know 1, which means we're going to times this. Okay? If this confuses you, I am going to erase this and then put a times for you, so you'll know exactly what we're doing. Times 1. Okay? So that basically means the cost equals 20 plus 10 times 1. So these two will add together because we know the cost of the t-shirt is $10. We've got 1 t-shirt, as you can see right there. So it'll be 10 times 1. Okay? So if we looked at that, 10 times 1, what would our total cost be? Our total cost would be what? You got it, $30. So the ordered pair for one, which is the t-shirt, see that T right there? That stands for one t-shirt. I'm going to put a comma right here. The total cost of that, shipping and the t-shirt cost, is $30. Fantastic. You all did a great job on that. But now it says, let's take a look at this as far as that. We've got that for A. Okay. I want to keep this on here for you so you can see it because it's a little different. It's a little, because we have really a two-parter for this. So I'm going to go up a little bit. I'm going to move this up just a little bit. There you go. So it says choose an ordered pair that lies on your graph in part A. Interpret it in the context of the problem. And that's what I'm going to do for you right now. Okay? So I'm going to make let me get my wonderful pencil. As we know, the pencil, you can't lose this digital pencil. I like that. Well, there's always a way, but we're not going to talk about that. So I'm going to make a little graph right quick. Okay? Let's make a little graph. Here's a graph. All right? And we're going to go from here, and I'm just going to go just with some regular costs. $10, $20, $30, and I'll say $40 or whatever. It doesn't matter. This is all hypothetical. But if we went, we can change the number of the price of t-shirts and the volume of it, and that price would change. Okay, if we went to 2, it'd be $20, and go on and go on and go on and go on as far as what the actual cost would be of the actual t-shirts. All right, so we know this stands for, I'm going to put a T right here because this stands for t-shirt. This part of it, okay, is the t-shirts. That's the vertical. The horizontal would represent the amount of t-shirts. 1, 2, 3, 4. Put one right here, right there, right there, right there. And I can do this too. I'm just trying to kind of like dress this up a little bit. We don't really have to do that. I just want to dress it up just a little bit, and that way you can see exactly what's this and what's that. So if we did this, because it's asking for an actual graph, we would look at this and we would do the actual graph of what everything would basically cost. Okay, so we know our first cost would be, if we looked at this, and let's do we will do, let's see, well, if the cost of it, let's take a look at it and we can see the actual cost of the actual t-shirts. And let's say it's at $20 as far as that. So we'll start at that particular point, and you will see it basically rise as we go. We could do it at $10, but we'll do it at 20, and you'll see that arrow start to rise every time we get to a little more of what's this and what's that. Okay, and go from there. So we know the first one is $30. All right, so watch my arrow. Watch what it's going to do. That's the beginning cost. At the 1 point, there it is, and it keeps going up, and it would just keep climbing up. Okay, so here is 1, and this is the actual point. So we see at this point right here at $30, that's that one t-shirt. Remember we talked about the one t-shirt, the total cost is that. You've got it. So now we can see the actual total cost. Oops, I want to do this right. My eyes are phasing me, kind of doing some tricks on me as far as that. So I'm going to change this real quick. This right here stands, I apologize, this stands for the t-shirt. This right here, let me erase this real quick so you'll know, and now it'll make more sense to you. I didn't pay attention to that. I'm glad I caught it before we ended it. This stands for the cost. So the vertical line is the cost. $10, $20, $30, $40 as far as that. And now we have the amount of t-shirts, the quantity of t-shirts, okay? The amount of t-shirts, 1, 2, 3, 4. So as we can see, at one t-shirt, the cost is $30. Remember, if we look at this right here, now we got total cost $30 because we've got the equation, which is cost equals $20 plus $10 for the t-shirt. This is the shipping cost, of course, times 1 t-shirt is $30. Okay, the ordered pair, as you can see right here, is the one. The T represents the one t-shirt, and then the total cost represents the 30. Okay, and you see it right here on the actual graph. All right, good job. Excellent. Excellent job, you all. Okay, let's go now to B. It says choose. We're doing B now. Let me go down to it right quick. Let me get on this. It says for B, and I'll put it right here. We're still on number 19. You got it. Choose an ordered pair that lies on your graph as far as that. So we already looked at the actual graph. We know what happens. So what we have chose, we had, of course, what, 1 and 30 as far as the actual graph was concerned. So that basically means we're going to choose that. So if we had, so we would make it look something like this: the ordered pair, okay, the ordered pair. We talked about that before. It's really simple. The ordered pair for this would be what? 1 and 30. Okay? And we did that. I'll do this a quick graph real quick so you can see it. It'd be 1 and 30, so you'll know exactly what's going on. This stands for what? Cost. This stands for the t-shirts. Okay? And I'll just put 30 right here, and I'll put 1 right here, and we know they met up at this particular point. I'll just put that right there. So that's how we come up with the ordered pair, and you can see exactly where it's at. It's at 1 for the t-shirt, and the total cost is $30. Okay, that's how we have that. That's how that would basically look, and that's how we would write that, okay, for the ordered pair, which is 1 and 30. All right, good job. You all did real good on this one. Okay, now let's take a look at number 21. It's right here. It says a hurricane has wind speeds that are greater than or equal to 74 miles per hour. Write an inequality to represent the possible wind speeds during an actual hurricane. All right, this is number 21 right here. So let's first deal with what we do. We're going to write out the actual words, of course, as far as the actual equation. We're going to write first what? Wind speed. Okay, it talks about wind speed. It says wind speeds are what? Are greater than. So the wind speed would be greater than or equal to what? 74, you got it, miles per hour. You got it. Way to go. Okay, what is our variable going to be? Let's make our variable what? You got it. Let's use W, because that would represent wind. Remember, you can do however you want. You can put X or Y, but it's always best to kind of use a actual letter that's similar to the word that you want it to represent. So in this case, of course, W for wind. So let W be the wind speeds. Okay? Variable is W. Okay? Now, the inequality. What is the inequality of this going to be? The inequality is going to be what? W, all right, either greater than or equal to, see that sign, greater than or equal to what? 74. You got it. So an inequality is when is greater than or equal to 74. You got it. That's it. That's your answer right there. And I know you all got it. You did a great job. Matter of fact, I'm going to do it twice. There you go. Excellent. This, of course, is number 21. Very, very simple. You set up the actual inequality that when is greater than or equal to 74. You can see it right here. The inequality is when it's greater than or equal to 74. Excellent job. Good job. You all keep it going. You all got all of those correct. I am really, really impressed.